Binomial check. Determine if each of the following represents a binomial experiment. There are certain requirements or conditions that we need to check to determine if an experiment is binomial. There is a fixed number of trials. This number is called n. It has to be finite. It cannot be infinite. The number of trials need to stop. Each trial must be independent. We need to know that one trial probability does not influence the other. Each of the trial has two possible outcomes only. This is why it is called binomial. One is labeled as success and the other one is failure. Success and failures are just simply the convention naming for the outcomes. They have nothing to do with the negative or positive meaning. If we're interested in the number of incorrect, for example, then success would be incorrect. And so success doesn't always mean a positive thing in a binomial experiment. Success just simply means what is this the outcome that we are interested in. And lastly, we need to have the same probability of success called lowercase p for each trial. And because of that, the probability of each failure must be fixed 1 minus p, whether it is a success or failure. And so those are the conditions for the binomial experiment. For example, a fair coin is tossed 10 times. Let x be the number of times the coin lands heads. And so in this case, we are interested in the number of heads, and so getting a head is a success in this case. The first condition, is there a number of fixed trial? And yes, we toss the coin 10 times, so n equal 10. This is fixed. Are they independent? Yes, they are independent because the coin tosses are independent. In each trial, are there only two outcomes? Yes, whether we get a head or a tail. What is the probability of success? The probability of success or getting a head is p equals 0.5. Therefore, the probability of getting a tail is 1 minus 0.5 or 0.5. And so all of the conditions are met. We say that yes, this is a binomial experiment. B. 5 basketball players each attempt a free throw. Let x be the number of free throws made. And so if they made it, it is a success. Is there a number of fixed trial? Yes, n equals 5. 5 throws. Are they independent? Well, we can assume independent because there are 5 basketball players and we assume that they throw the balls independently. Are there only 2 possible outcomes in each trial? Yes, whether they make it or they don't make it. If they make it, it is a success. If they don't make it, it is a failure. Is the probability of success the same in each trial? Is the little p the same? And the answer is no, they're not the same, because we cannot assume that the skill of each of the players are equally likely. And so because the last condition is not met, we say that no, this is not a binomial experiment. A die is rolled repeatedly. Let x be the number of rolls it takes to get 6. Is there a number of fixed trial? No. In this case, there is no fixed trials because we can do this repeatedly. There is no finite number of rolls. And so, because the first condition that we check is not satisfied, we can just simply say, no, this is not a binomial experiment, and we can just stop. We do not need to check other conditions. A basketball team is selecting a captain. The names of all of the seniors are put into a hat, and the first three are drawn will be captains. The names are not replaced once they are drawn. One person cannot be two captains. Let X be the number of captains who play the same position. This experiment is done without replacement, not replaced, meaning this is without replacement. And since this is done without replacement, we know that the trials are not independent. And since the trials are not independent, we're going to simply say that no, this is not a binomial experiment.